Admath book, and we are doing the questions from exercise 15.7, and the question first one is given there, y equals to x plus 5, that expression show that. So first part actually differentiate our relevant with the differentiation. Then the second question, hence find this one. With the help of differentiation we can find out this answer. This is one of the Cambridge pattern question. Always that type of questions would come in your exam. So let we start from here. It is given there, y equals to x plus 5 divided by root over, this is you can write as a twice x minus 1 to the power half. That is the expression. So we all know we have one rule for differentiation, which is called u by v. We needed to apply here this rule. This is the rule actually, v du by dx, then minus u dv by dx divided by v square. This is the rule for the differentiation, quotient rule. So let me consider u as x plus 5 from here, and v is the expression here, 2x minus 1 to the power half. So we needed to differentiate du by dx gives us 1, and dv by dx, if we differentiate, it gives us half into 2x minus 1 to the power half minus 1, which is minus half, and into coefficient of x is 2, so we can cut out this 2 and 2. So finally we got from here 2x minus 1 to the power minus half. So that is our expression of this question. Let's put all the thing here, so we can write it dy by dx. Rule is v, so this is our v, 2x minus 1 to the power half, and du by dx, which we got 1, then minus u is here x plus 5, and dv by dx, which is twice x plus 1 to the power minus half, and denominator v square, and there is a square root, so we can write it 2x minus 1 itself, because half square means without square you can write it. So on the top part we needed to simplify. It is having with 2x minus 1 to the power half, but minus that one is, we can write it x plus 5 divided by 2x plus 1 to the power half as well, and denominator is twice x minus 1. So the expression is 2x not plus 1, its expression is 2x minus 1, sorry for that, 2x minus 1. Okay, so 2x minus 1 minus 1. So we're going to simplify. If we simplify it, it gives us denominator is 2x minus 1, 2x minus 1 to the power half, and numerator it's consider 1, and we can make LCM, then it gives us twice x minus 1, then minus x minus 5, its denominator as well written here twice x minus 1. So finally we got from here, on the top it is twice x minus x, which is x minus 6, and the bottom it is 2x minus 1 half plus 1, which is 3 by 2. So this is our first part of this question, 3 by 2, x minus 6. So it is written here 3 by 2 as well. So we also can write it x minus 6 divided by square root of 2x minus 1 to the power 3. Is it the same thing the way it is written here? Now the second part of this question, second part is very simple. In that case it is written, so if we differentiate it, differentiation of this y dy by dx, we got the expression this one, d by dx, if we differentiate. Now the same thing is given as a integration, see the same thing, so we do not need to do it. So directly you can write it this one, if we integrate from there, integration with respect to dx with the same expression, if we do it, then it converted to the x plus 5 bar this one, so it's reverse and vice versa. So b we can write it, so integration of what it is written there, root of 2x minus 1 to the power 3 dx they are asking. So this is the result of the differentiation. If we integrate the result of the differentiation, then we would come back to the first part of this expression, so which is written here, x plus 5 divided by root 2x minus 1 plus c as a constant. We needed to write only the extra part is we needed to write plus c here. That is only the extra part. So this is one of the common question pattern type in Cambridge AdMath syllabus, in the board exam questions especially. So a lot of questions are here like this. We are going to move to few more questions from here. Now I'm going to explain the question number 2 from here. 2 is written differentiate with respect to as this one. So if we do it with the differentiation 2a, it gives us definitely 5 inside what written there, 3x square minus 1, 5 minus 1 is 4, into inside if we differentiate 3x square minus 1, then it gives us 6x. I wrote here directly, so that will be the answer is 3 6 the 30, 5 6 the 30, x 3x square minus 1 to the power 4. That is the answer of the differentiation of that expression 2a. Now the question is they're asking to find integration of x of this one. This is not possible to do it directly because having with the power 4. So we can do one thing, we can take the help from the differentiation part to do that question. So see the question, it is written here like this. Can I write this question with the help of the differentiation part like that way? I'm going to use the different color here. It is written here x of 3x square minus 1 to the power 4, then dx is written. Almost things are same, just except the 30. So we can insert 130 inside by keeping a 130 outer side as well, but we needed to give it as a 1 by 30 because if we multiply 1 by 30 into 30, the expression would be the same here, the similar expression. So now we can write the expression like 1 by 30 into, it is differentiation. This is the answer of the differentiation, so we can back to our previous expression. So this is our expression of the first expression. So 1 by 30 of that one we are going to write now, which is 3x square minus 1 to the power 5. So after integration we need to plus c, and that would be the answer of this question. Let's move to the question number 3 now. It is written here x ln x. If we differentiate 3a as a x ln x, divide dx of x ln x, and it would gives us x divide dx of ln x, because we applied here the formula which is uv rule. If you don't know the basic rule of the differentiation, there is a chapter here, differentiation part, so you can see from there, or click on the I button from the right top for seeing the differentiation equation. X into ln x, differentiation is 1 by x, plus then ln x, and differentiation of x is 1, we know. So finally we got from here 1 plus ln x, and that would be the answer for the first part. It is then the b, it is written here. Let me go for the b. I'm going to change the color again. B is written here ln x. Directly they are asking to find out the ln x, but we cannot apply the ln x directly. I need that expression. How to do that? How we can do this one? So we have to add 1 here to do that. So can you write the expression like this? Ln x 1 plus ln x, then minus 1, because 1 and 1 cancel out, dx. Then we can write it integration of 1 plus ln x dx. This is the first expression, and this minus part make you isolate from here 1 dx. We can write it from here, the same meaning is there. So see, the differentiation result is this, so we can move to directly here now as integration, so which is gives us x ln x, and that part we can integrate 1. If we integrate, we got the x from there, then plus c. So this is our answer of this question. Let's move to the question number 5. It is written here y equals to this one, dy by dx, the first expression. 5 we are doing here. We need to apply the product rule, dy by dx, which is x d by dx of root x square minus 4, then plus root x square minus 4 d by dx of x. So it gives us x into differentiation of this one, half x square minus 4, half minus 1, which is minus half, then into 2x we have to write here, plus this one x square minus 4, differentiation of x is 1. So we can write that expression like this. So we can cut out this 2 and 2, x into x, which is x square divided by root, we can write x square minus 4 as a denominator, plus this is also root x square minus 4. So we can simplify that expression to make a single expression, which is x square minus 4 is the LCM, and on the top it is having with x square plus root x square minus 4 into root x square minus 4. It gives us x square minus 4 again, root cancel. So it is 2x square minus 4 divided by root x square minus 4 is the answer of the first part, dy by dx. Now the second one is written here. They're asking to find out this. So it's easy. We needed to take the help from the differentiation part. Let you use different color as before. It is written the expression x square minus 2, and the denominator is also x square minus 4. So it's almost the same thing, only difference is the 2. So we can insert 1 2 inside by keeping half on the outside, because half and 2 cancel out, so expression would be the same here, dx. If we, so that expression if we integrate, so this is the differentiation result, it is inside the integration. So we would get the part, it is written here already, without the terms as a y. So half into, then we have to write half into x square minus 4 plus c. This is actually we use the reverse differentiation to get the value of y from here. So that is the total working of this question. Let's move to the question number, another question, different question, exponential, which is question number 7. Question 7, it is written here that expression. So differentiation according to the, we have to apply the product rule for x e to the power 2x x, then let me write here d by dx of e to the power 2x, then plus e to the power 2x d by dx of x. The first part actually x is the base, we have to apply the product rule, but the second part we can write here half as a constant, then d by dx of e to the power 2x only. So now let me write your result. E to the power 2x, coefficient of x we needed to write in front of it, which is 2x e to the power 2x according to the rule of differentiation, then plus e to the power 2x from here we got, because d by dx of x is 1. Then next part is minus half into 2, because coefficient of x is 2 we got from here, then e to the power 2x as well. So finally we can write it 2x e to the power 2x plus e to the power 2x, then minus e to the power 2x from here as well. So the main part is we can cut out these two, and we got the result 2x e to the power 2x. This is our answer of this differentiation. Now the question is, say the almost the same thing is written for the integration. So we got this result, we can take help from here. So b part is here, say integration of x e to the power 2x is written there dx, then c it is having with the 2, so we need to insert a 2 here, and outside we can keep half, then half of that expression actually it was written before like this. So the result before differentiation we needed to put here, so x e to the power 2x minus e to the power 2x divided by 2 plus c, and this is the answer of this integration. Hope you understood the questions we are solving from here. Question number 7, which is with the help of differentiation we are doing the integration. Let's move to the question number 8. It is written here, science of differentiation, first part. So let me differentiate first 8a d by dx. We have to apply here the quotient rule. U is here sin x and v is given here 1 minus cos x, 1 minus cos x. So if we differentiate du by dx, we got from here cos x, and dv by dx, definitely it would be 1 is gives us 0, and cos x differentiation is minus sin x, so minus minus plus sin x we have to write here. Now let me put our final result, so which is v du by dx, v du by which is 1 minus cos x on the top into cos x, then minus sin x into sin x as a numerator, and denominator is, it is 1 minus cos x whole square, 1 minus cos x whole square. Now break down on the top, which is cos x minus cos square x, then minus sin square x, it is written here, and its denominator is written here, say 1 minus cos x minus 1, cos x minus 1 whole square. Sorry, it is written actually 1 minus cos x whole square. Let me write it as it is, 1 minus cos x whole square. So we are going to prove it like this. So it shows that one of the factor from the denominator it cancel out, I think. So let me change the sin square x from the top first. We know that sin square x is 1 minus cos square x. We are putting it here, cos square x minus 1 minus cos square x. So then as a denominator we can write it, if it is written there 1 minus cos x whole square, we also can write it cos x minus 1 whole square, just only the difference is 1 minus sign. Minus we can cancel out inside, so we can write it like this. So on the numerator it is cos x minus cos square x, then minus 1, then final one plus cos square x as well, cos square x, and denominator it was cos x minus 1 whole square. So you can cancel out these two. One of the factor is cos x minus 1 on the top, we can write it, and denominator is cos x minus 1 whole square, so you can cancel out 1, and the answer of this question is 1 by cos x minus 1. So if we compare with this expression, it is written here, so you can say value of the k equals to 1 we got from here. This is the first part of the answer question. So let we do the question number B from here. Usually let's using the different color B, it is written here that expression 5, so we can take the 5 out from there, and expression is 1 divided by cos x minus 1 integration of this, and 5 integrate of 1 by cos x minus 1 is the same thing, plus dx, it is written dx, you can write it. So see the answer of the differentiation of this. So if we integrate that one, then definitely we would get from our integration sin x divided by 1 minus cos x. So let me write this, 5 into sin x divided by 1 minus cos x, and that is the answer of that expression, plus c. So this is the answer of this question. Move to the question number 11 now. It is differentiation of this, but we have to apply the product rule first. It is written here 2x cube, then d by dx, so we can write it ln x. Then next part is ln x d by dx of 2x cube, 2x cube. So from here we got 2x cube into 1 by x plus then ln x into, if we differentiate that one, this is 6 x square we got from there. So finally we can write it, we can cut 1x from there, 1x from there, so we can write 1x. So it would be 2x square from the top part, then plus 6x square ln x is the answer of the first part of this question. So now the question is they're asking to do that one. So how to do that one? I'm going to write it usually with the different color, say B of this question. It is written here x square ln x, but we have to write that expression inside. Let me try to write this one. So we needed to find out this one. This is our target. So from the answer of the previous question, can we write like this? Integration of 2x square plus 6x square ln x, it is written there. We can write it. If we integrate this one dx, then definitely we would get from there 2x cube ln x plus c as a constant of integration. Now let me make it subject this one, so we can split it like this. Say integration of 2x square dx plus 6 of x square ln x dx. We can write it like this from the left side, and on the right side it is 2x cube ln x plus c as well. So if we integrate this one to x square, it gives us to x cube by 3, then plus 6 of that expression x square ln x dx equals to 2x cube ln x plus c. Now let me make this one as a subject. We can write it x square ln x dx equals to 2x cube ln x plus 2x cube by 3. Sorry, it would not be plus because we have to write with the minus sign. It is having with the left side plus sign, so it goes to the right side with a minus sign, and plus c. But there is a 6 in front of this one, so if we remove the 6, then it is x square ln x dx. You can write it 2x cube by 6 to x cube ln x by 6. Then next one is 2x cube divided by 3 into 6, and this constant is c by 6. So we can cut out 3 here, so it would be 1 by 3 x cube ln x, and we can write it, we can cut out say 3, so minus x cube by 3 is the 9 plus c by 6. And interesting matter is we can remove this c by 6. This is also another constant by writing like this 1 by 3 x cube ln x minus x cube by 9, so we can write here as a k. This is a constant. 6 by 6 is a constant. We also can write c here. This is nothing wrong, so that would be the answer of this question. Hope you understood the question we are solving from here. Let's move to other question, which is question number 12. Our target is to do right now. This is written here x cos x. So first differentiation d by dx of x cos x. If we differentiate it, then it would be x d by dx of cos x plus, you can write it cos x d by dx of x. So it gives us x, and into cos x differentiation is minus sin x plus cos x into 1. So finally we got from here minus x sin x plus cos x. This is our answer of the differentiation, but the question they are asking to do this one. So like before, we also can write it for the b part. If we integrate the whole thing, minus x sin x plus cos x dx, then we would get from there x cos x plus c. Now let me make this one as a subject, then we can write it, say minus sign is outside, x sin x dx, then plus cos x dx, this is another expression, equals to x cos x plus c, you can write. So we are going to make this one as a subject, x sin x dx. If we integrate the cos x, we would get from there sin x, positive sin x. Then on the right side it is written here x cos x plus c. So minus x, let me write everything on the right side, dx equals to minus sin x plus x cos x plus c. So we needed to remove the minus sign from the left side, which you can write x sin x equals to positive sine x, then minus x cos x, then minus c. So we can leave our answer here, no problem. This is also the answer. We also can leave it sine x minus x cos x plus k. This is also k, we can replace by minus c. We replace this constant by minus c because it is also a constant. We also can write the answer like that, so don't make any confusion about that. Plus c also, minus c, because it's all about the constant, so we also can write all are the right answer. So hope you understood the question we have done for you. Let's move to the last question from this exercise, which is question number 13. It is written there, y expression is that one. They're asking to find out dy by dx. This one we're going to prove it. So first, let we differentiate with the product rule. Question 13 we're doing. Say e to the power 2x first, then dy by dx of the whole expression, which is sine 2x plus cos 2x, then plus sine 2x plus cos 2x, and dy by dx of e to the power twice x. So let us differentiate e to the power twice x into this one. If we differentiate, we got from there 2 cos 2x, because differentiation of the sign is, it gives us positive cos, and constant to we need to write as a multiplication in front of it. Then cos x, if we differentiate, then it gives us minus 2 sine 2x, because cos is alternate is the sign we have to write here. Then plus, it is written here, sine 2x plus cos 2x into 2 e to the power 2x. So let me finish it. Then the expression you can write 2 e to the power 2x cos 2x minus 2 e to the power 2x sine 2x, then plus 2 e to the power 2x sine 2x plus 2 e to the power 2x cos 2x. This is the total expression. So let me see, 2e2x sine 2x, 2e2x, we can cut out that 2 expression, then only remaining the same expression, so we can add. So we got from here 4 e to the power twice x cos twice x. So this is our answer, or we are going to show this part is written here. So now the integration part is very simple and easy for us. It is written with the only integration part b here, ex, only here absent, the 4 is absent in that part. So we can insert a 4 here by keeping 1 by 4 on the outside to do that question. So this is the answer of the differentiation. If we integrate this one, then definitely we would get what written as a y here. So let we write there, then 1 by 4 into the whole part of the previous part, we are going to write e to the twice x sine twice x plus cos twice x. This is the expression, then plus c, and this is the answer of this integration part.